when your home disrupts your microbiome. The microbiome is absolutely one of the most critical organ systems, if you want to say, in our body, right? It influences our immune system, it influences our mental health, it influences digestion, it influences just about every physiological system in our body. There's a lot of important conversation around how mental health and stress influence the microbiome, how toxins and glyphosates and heavy metals influence the microbiome, how our diet obviously influences the microbiome, on and on. How often do you hear a conversation around how the homes, the schools, the buildings that we are in influence our microbiome? Almost never, right? That's just a conversation that we don't really have. Except I would argue that the homes, our buildings, our schools are impacting our microbiome in more significant ways than you can possibly imagine, and are the reason why some individuals have the most severely disrupted gastrointestinal tracts and worse, most disrupted microbiomes that you can possibly imagine. And this is a conversation around that. I've done a lot of training, and the main reason for this training is to better understand why the children that I serve struggle the way they do. And a big area of my focus and attention has been on dampness and mold. And one of the things that I had realized, now this is almost a decade ago, is that children that were in these damp environments had severely disrupted gastrointestinal tracts and microbiomes. And it wasn't just that their intestinal tracts and microbiomes were disrupted. It was the way in which their gastrointestinal tracts and microbiomes responded, or I should say, did not respond to treatment. These are kids that you would change their diet and put them on the best, cleanest diet you can possibly imagine, and nothing would happen. You would put them on probiotics, some of them would get more sick. You would do various types of supplements, they would barely work, and everything was just stuck. To add to that, even when I did effectively treat these children, and I would put them on antifungals and do all of these things to shape their microbiome and gut, things would get better, only to fall apart again. And these observations had me question what else was going on. Because if it was just the microbiome, right, if it was just the gut that we were trying to fix, then we should have been able to fix it. With these various tools that we have, we should have been able to get things better, and these children should have recovered. So what else was part of the picture? And that is where this conversation of downstream immuno-metabolic effects come in. Now, this is a hypothesis. It's something that several practitioners that I know that are really kind of marching ahead and really trying to push the envelope are looking at. In terms of how does our metabolic functioning, our mitochondria, influence the immune system, and then how does that influence the gut and the microbiome? And really, this is the heart of this presentation. How do these things come together to then cause the challenges or improvements that we hope for in the children that we serve? I don't want to discount the role of other compounds and toxins, glyphosates, heavy metals, processed foods, the SAD diet, right? The standard American diet, phthalates, COVID, air pollution. You can add multiple other things to this, all disrupt the gut. They all disrupt the microbiome. They all disrupt the mitochondria. And really, the concept that we should be looking at is the total toxic load. This is a concept that has been discussed by my mentor, Dr. Nathan, for years, right? And it's really this bucket. You have a bucket, and at a certain point, if that bucket starts overflowing, that overflow of toxic load causes significant disruption within the system as a whole, and you can argue within the gut and microbiome, which then causes all kinds of other health challenges. Now, a lot of people focus on, well, let's get rid of plastics and this and that, which I 100% agree with. But one of the things that I have found that gets missed all the time from this conversation is this sinister exposure that is probably more dangerous and significant than what most people can wrap their heads around. And it is more common than we can possibly imagine. So, this is a US EPA study where, depending on the region and the area that was tested, on average, 1 in 3 homes have dampness and mold. And depending on other areas, it could be even higher. Once you add climate events, including hurricanes and flooding, 1 in 2 homes get impacted, with 1 in 5 homes having severe amounts of mold growth. And a lot of these people do not have the means or funds to address this exposure, so they just paint the walls and fix a few things, and they move on with their life until people start getting sick. And unfortunately, when some people get sick, they get really sick. And unfortunately, when some kids get sick, they start looking like they're autistic, or they start having weird patterns of anxiety, weird patterns of aggression, weird learning disabilities, and these children just become incapacitated. And it's truly heartbreaking. It's truly heartbreaking to see what is happening, because these children are getting robbed of their vitality. They're getting robbed of their ability to function. They're getting robbed of their ability to socialize. They're getting robbed of their ability to thrive and succeed. And that is why this conversation is so important. When we introduced sheetrock, drywall, gypsum board, whatever you want to call it, we did something that was not very intelligent. We basically introduced a matrix of a petri dish within our homes that is ready to grow mold the second you add humidity to it. So drywall is gypsum board sandwiching calcium carbonate. The calcium carbonate by itself does not grow mold. But guess what is in the heavy paper that is sandwiching the calcium carbonate? Mold. The heavy paper that is in drywall, the paper that you see right there, that is derived from tree bark. Guess what is naturally occurring in tree bark? Mold spores. So we have literally embedded the inside of our homes with a matrix that is able and quickly capable of growing mold the second you add water. And then one of the problems on top of that is, with our push to make homes energy efficient, which is great, right? We have gotten airtight construction. We have created air sealing. We have insulated doors and windows, which means what? These homes do not breathe. So you have this petri dish of mold ready to grow now in an encapsulated environment that does not breathe, right? And with many people and where they live, it's either too hot, too humid, too cold, right? So they do not leave their windows open. They can't leave their windows open. So you run our air conditioners, which only recirculates whatever is inside these homes, which means contaminants are readily produced and may build up to much higher concentrations that are found on the outside. And we have created unknowingly an epidemic of indoor air contamination because of some of these things. But when we say mold, it's really critical to understand that mold is actually the least significant part of this. So for those that say mold can't cause illness, they're actually right. The mold spores cannot cause illness. Now, usually when there's contamination, there's multiple molds with multiple mycotoxins regularly. And in addition to that, you get gram-positives and gram-negatives bacteria, which is what Dr. Shoemaker talks about. And he is actually the one that many, many years ago coined the term biotoxin illness. You get microbial particulates, which is where a lot of the ENT inflammation, so those kids that have chronic congestion, they get recurrent ear infections, they're coughing all the time, they're just allergic and reactive. That is all these microbial particulates. Microbial volatile compounds can also cause a lot of inflammation, particularly in the airways. These beta-glucans and galactomannans can also cause a lot of inflammation. These lipopolysaccharides can cause significant and horrific inflammation in the nervous system, but can also activate the immune system within our body. And these gram-positive bacteria, these actinomycetes, can create a compound called valinomycin. And we're going to talk about why that's important. So you have to realize that when there's indoor contamination from a water event or excess moisture, you get this soup of biological toxins. So imagine a chain smoker that is sitting in your child's bedroom wall that is literally chain smoking, and there is smoke that you can't see. Most people can't smell it. Some people can smell a musty smell, not all. So you can't see it. You can't really know that it's there. It's not like the ceiling is about to collapse, because a lot of times the moisture events are behind walls or behind cabinets or behind areas that you can't see. Sometimes they're in crawl spaces. You can't see it, except that crawl space is communicating with our homes. And this chain smoker is releasing literally a soup of biological toxins that makes us sick. Hence the perfect coined term, biotoxin illness. When babies are exposed to this biotoxin illness, early on, they start developing horrific colic. And we're not talking the baby that cries for 5 minutes at a time. These are babies that are difficult to console. They're very poor sleepers, and they're just reactive all the time. Why would babies be severely colicky? It turns out that that is the first sign of neuroinflammation taking fold right before our eyes. And there are studies that have demonstrated that infants who have severe colic tend to have higher rates of autism. This is neuroinflammation taking place in the earliest form. A lot of these babies also develop reflux that goes way beyond the first 6 months of life. Why do they develop reflux? That is the first sign of their gastrointestinal tract starting to fall apart. A baby that refluxes, and I'm not talking a little poop, right, occasionally because they overfeed. I'm talking the baby that just constantly vomits, and you put them on hypoallergenic formula, and you do this and you do that, and they're just constantly refluxing and they're constantly uncomfortable. That's their gastrointestinal tract starting to struggle. And that is why these children go on to develop multiple food sensitivities. Some of them go on to develop food allergies. Where do these come from? These are due to intestinal integrity loss. This is a leaky gut that is unfolding before our eyes. And there are so many kids that present with exactly this picture that it's difficult to ignore, except we ignore it all the time. We look at one thing, colic has nothing to do with autism. Reflux has nothing to do with autism. None of these things are related until you see that they are. This eczema, asthma, allergies is further immune dysregulation. This ENT congestion is the sign of all of the microbial particulates. The sensory distortions are signs of inflammation within the nervous system that distorts the sensory pathways. And we're going to talk about what this is about. This is the early sign of mitochondrial disease. Now, some people say, well, exposure in the environment can't cause any illness. You ingest these toxins, and ingestion of the toxins has been shown to cause illness, but exposure in the home can't be, or in the schools. 20% of schools have mold. A lot of office buildings have mold. No, this exposure can't be. 4 different studies that have clearly demonstrated that when individuals are in damp environments, these mycotoxins can absolutely make it into the bloodstream. So for anyone that denies this, I encourage you all to go look at these studies yourself and see what they show, because mycotoxins absolutely make it into the bloodstream from environmental exposure. But it's not just the mycotoxins. This is a study looking at endotoxin exposure. So you can see, depending multiple different environments from homes to various industrial areas, you can absolutely get inhalation and absorption of endotoxins as well. So environmental exposure does indeed cause systemic exposure, and that becomes a problem. It passes through the placenta. So for a pregnant mom that is living in a damp home, those toxins, at least the mycotoxins, we don't know about the endotoxins, but at least the mycotoxins are known to pass through the placenta. These mycotoxins, again, we don't know about the endotoxins, do pass through the breast milk and are actually concentrated in the breast milk. So every time that baby goes to feed, they're getting a dose of these mycotoxins. Now, why is that important? That's part of what we're going to talk about. Imagine what happens to a baby who has yet to form their microbiome. So their microbiome is maturing, their immune system is priming, their gastrointestinal tract is forming. They don't have much capacity to detoxify. What happens to these babies when they're exposed long enough and that exposure is severe enough? The answer is we don't know. We don't know. What I can tell you clinically is for babies that have significant exposure in these damp environments, bad things can happen. I believe that a significant, and we don't know the exact percentage, of what we call autism is due to this very exposure. Because the gastrointestinal tract is disrupted, the microbiome is disrupted, the immune system is disrupted, the mitochondria is disrupted, and that collectively causes significant and severe systemic and neurological dysfunction. What about the microbiome? Because this is a conversation around the microbiome, right? So, first thing we need to realize is when the microbiome is healthy, it protects us in a significant way. It aids and detoxifies the mycotoxins. So, literally, these mycotoxins can't get into our body when the gut and microbiome are healthy. It decreases the absorption and bioavailability of these mycotoxins, again, preventing them from making it into the body. And even if we're inhaling it, these mycotoxins are being pushed out of our body and nothing happens. And that's why 75% of the population generally is resistant and resilient to this exposure, where they may get a little brain fog, they may get a little whatever, but at the end of the day, nothing really phases them with this exposure. 25% of the population is susceptible, and we're going to talk about how that susceptibility takes place. I would argue that this same concept also applies to endotoxins. And when the gut is healthy, these endotoxins can't enter into our circulation in any significant way to cause harm. Now, when that changes, when there's dysbiosis, when there's gastrointestinal disruption, that's when the dam breaks and everything falls apart. And not only do you get reabsorption of these toxins and increased concentrations of these toxins within our body, but you actually even get bioactivation of mycotoxins that weren't a problem. So literally everything just falls apart when the gastrointestinal tract is no longer able to do its job. Before I present some of the studies, we need to consider some things. The direct effect of mycotoxins on the microbiome through inhalation and environmental exposure is not known. And a lot of the studies that I'm presenting in this first part, specifically around how mycotoxins affect the microbiome, are specifically around ingestion of mycotoxins. What we do know is mycotoxins that are inhaled, that go through the bloodstream, can enter the gut from the systemic circulation side, so essentially the back door, and that can cause a lot of inflammation. That we do know. We also know that mycotoxins are ultimately processed through the liver and dumped into the gastrointestinal tract from our bile, with our bile. Those mycotoxins are only degraded primarily through the microbiome. So yes, the liver does do some detoxification of these toxins, but really it's the microbiome that degrades these mycotoxins. So essentially when mycotoxins go through the circulation and get dumped in the bile, they're still relatively bioactive and can still cause harm through this secondary pass-through. But what we see through these direct studies is how mycotoxins affect various bacteria. Mycotoxins decrease the diversity of the gut microbiota, sometimes permanently. And to understand the significance of this, we just need to start by asking, where do most of our modern antibiotics come from? Molds, right? Penicillin, where does penicillin come from? Penicillium. Most of our modern antibiotics are literally mycotoxin derivatives. And these are studies, not that you need to pay attention to every single one, but these are studies. Now, this is mycotoxins in feed, again, not inhalation, but aflatoxin decreased phylogenetic diversity. Aflatoxin influenced all of these. You can go on. And for those of you who want, pause this and look at these studies. More studies looking at how these toxins affect the microbiome. But it's not the direct effect that's significant. It's what these toxins do, and I would argue the biotoxins as a whole. They actually alter the environment in which these microbes can grow. They cause marked changes in chyme composition, so that's kind of the soup of stuff that these bacteria grow in, as well as the environment in which these microbes can grow. So imagine there's a beautiful little town, right? And this town has nice homes, nothing fancy, very middle class, but middle class, nice homes. Everything is safe. Homes have cute little gardens. Everything's pretty. Everyone is happy to live there. Then something weird happens. And for some reason, the environment starts changing. The homes start kind of falling apart. Some gangsters start showing up. They start causing some problems. Next thing you know, a few period of time later, the gangsters have taken over. And this beautiful little town is now completely dilapidated. And there's crime everywhere, and everything is just a big disaster of a mess. In a sense, that transformation from beautiful home with upstanding, wonderful residents that only are there to live their lives, law-abiding, kind people, have now turned into mafioso gangsters that are ready to kill each other. That transformation is literally what I believe happens when there's exposure to damp environments. And this is part of what this conversation is about, why that happens. Mycotoxins influence short-chain fatty acids, and I'm sure a lot of you have heard how short-chain fatty acids are so critical. Butyrate is so critical for the health of our gut because butyric acid and short-chain fatty acids feed the enterocytes, feed the intestinal cells, which then helps them with their integrity, and they also influence the immune system. So it's critical in this feeding process. This food source is disrupted because of what these mycotoxins do to the gut environment. But what else do these toxins do? Because it's not the direct effect that is key. It's actually the secondary and tertiary effects that are key. So mycotoxins essentially disrupt every single part of our gut physiology. They disrupt these immunoglobulins. They can disrupt the microbiota. They can disrupt the mucin layer by disrupting goblet cells, which I didn't talk about. They can disrupt these tight junction proteins. They can cause these lymphocytes to infiltrate. They literally influence every single part of our gut barrier that we need to have a healthy gut. These are two different studies talking about how these mycotoxins can induce severe leaky gut. Why do these babies start developing reflux? Why do these babies start having food sensitivities? Why do they go on to develop food allergies? Because these mycotoxins are disrupting the gut barrier. Dawn disintegrates the human cacao 2 cell monolayer. What is that? That's basically how scientists study the gut lining. So basically, they grow a bunch of cells, single cells, in a petri dish to see how they're doing. And then they can do all kinds of studies to look at the integrity. And in this case, they add a little bit of this mycotoxin in tiny, tiny amounts. And they asked, what does that do? And they found like, oh, holy crap, it disrupts the entire gut barrier. It disrupted the gut barrier in tiny, tiny amounts. Why is that important? Well, a lot of people say, well, this is only if it's exposed and only mycotoxins get into the food, so this is only related to that. Until you realize that the damage and harm that comes from these toxins when these toxins are in systemic circulation, right? 4 different studies that we found that all say the same thing. You're in a damp environment, you inhale those toxins, it gets into your bloodstream, period, hard stop. This study is talking about how when these mycotoxins are coming from the basolateral side, which means they're coming in from this side, they're able to cause more significant intestinal damage and permeability than if you were to ingest them. Why the heck is that important? When these mycotoxins cause intestinal permeability, they allow food proteins and other proteins to enter. What does that do? It triggers a whole lot of inflammation, right? You get leaky gut, but that leaky gut can also trigger all kinds of reactions from autoimmunity to food intolerance to the disruption of the blood-brain barrier. What do we see in a lot of these kids? Disruption in the gut barrier, disruption in the blood-brain barrier, more food sensitivities than we know what to do with. And when this happens to a little baby, so considering the apparent lactational transfer of various mycotoxins, exposure of infants deserves special attention. I don't know how more clearly someone can say something. Even minor changes to a baby's gut barrier can result in allergies later stage in life. When children have allergies, the risk of autism increases 200 to 300%. And yet we ignore these connections, these profound connections that are screaming that damp environments are contributing to why these children are becoming so sick. And we focus on all of these other things, which I'm not saying we shouldn't, but we miss the elephant in the room. We miss the gorilla that is destroying the china shop, and we're focusing on everything else. This is why this conversation is so important. By weakening the gut immune response, mycotoxins allow the translocation of various pathogens. Now, in this case, they say, well, that is part of inflammatory bowel disease, which it is. And it turns out that children with or individuals with autism have significantly higher rates of inflammatory bowel disease. Why? Because their gut has been disrupted. Why is their gut being disrupted? Because of this exposure. But once you get these translocation of the microbes, guess what that does? It activates the immune system further, which further damages the gut, which further disrupts the gut barrier, and you get this vicious cycle that has no end. There's something weird that happens in addition to all of that. Mycotoxins suppress the host immune response. So this is something that is perhaps the most critical point of this entire presentation. And I believe that this is the reason why these kids and individuals are compromised at the gut level in profound ways. So first of all, these Pyrus patches are basically like the little bases, right? They're little police stations, right? And imagine if the police in given police stations just develop narcolepsy and just fall asleep, right? All right, the crime is taking place. You call 911, no one's answering. People are getting robbed. People are getting killed. Police are falling asleep. They're not even there. Impact on antigen presenting cells ultimately causes a reduction in T cell stimulatory capacity and a reduction in the production of intestinal. Now, in this case, they're saying immunoglobulins, and we're going to talk about the various immunoglobulins. and increased levels of various cytokines that are needed for critical signaling. What happens when the immune system falls asleep at the job? And how does that influence the microbiome? How does that influence the gut? That is the heart of this conversation. And that is where I believe the key is in understanding how to help these individuals. So, how does the immune system shape the microbiome? To ask that question, or to answer that question, how would a healthy police force, right, where they do their job, they don't overreact, and they're friends and they're part of their community and they protect their community, they shape their community. A gangster shows up, the police car is there, is like, sir, you need to leave because you're not welcome in our community, right? The bad actors are kept in check. The law-abiding, kind citizens that live there are protected. They're attended to, right? The police show up with groceries. Here you go. You needed some help. Let me help you, right? Imagine this idyllic scenario, right? Sad reality is that it's not always that idyllic, but imagine that. In a way, that may be exactly what is happening within the gut. Now, I shared this study because it's ultimately a lot more complicated than that, right? We know that the microbiome influences the immune system. The immune system as a whole is very, very complicated. And for me to go over all of this would take hours. But we're going to simplify this and look at it in a much more simplistic way that is much easier to understand. So macrophages are one of our, primary innate immune cells. They're kind of the frontline guards, right? That protect us. Macrophages are an essential population of tissue-specific innate immune cells that function as housekeepers. The resident gut macrophages are usually considered as major key gatekeepers and play a role in engulfing pathogens. So when the bad actor shows up, right, that gangster that's about to go rob some people or do, whatever awful thing, hurt the citizens, they show up, they engulf that person and just take them away. So they influence inflammation and wound healing. Now, how these macrophages behave and communicate is essential for regulating the gut microbiota, and numerous studies have demonstrated that macrophages, when they're asleep at the job, lead to large alterations in the intestinal bacterial profile. These innate cells, right, the front lines, and there are multiple of them, right? Dendritic cells, natural killer cells, neutrophils, are important for clearing fungi. Now, imagine within this town, you have some people that are not like the outside crazy gangsters that are going to shoot up everyone, but they have some problems, right? They have some issues, but overall, they're good people. And as long as everyone around them is healthy, and as long as the police force is, checking in on them, hey, so and so, how are you doing? Oh, I was struggling today, but I'm all right. I'm okay. And they keep being okay. It turns out that Candida in particular is a normal commensal, meaning it's a normal part of the community. But Candida has a dark side to it. There's the Candida that is the commensal, and it's nice, and it's normal, and it functions, and it actually helps regulate the immune system. But when the environment gets funky, Candida can turn into a monster. And it becomes invasive. It starts spitting out these hyphae and actually starts going into the tissue of the gut and literally dissolving the tissue for it to be able to penetrate. So it literally goes through a psychotic break, morphs into the ugliest, meanest gangster you can possibly imagine, and just goes buck wild. When the police force and the community is surrounding Candida, it's kind and benign. When that disappears, Candida has its psychotic break and starts destroying everything around it. And we're going to talk about this a little bit more. In the absence of T cells, right? T cells are one of our humoral immune cells, right? In the absence of T cells, the trajectory of the gut microbiota becomes altered. Why? Because T cells are kind of talking to everyone else and coordinating the immune function. And when one of the coordinators of the immune function is asleep at the job, it's like air traffic control, right? They're controlling everything like you do this, you do that. Airplane crash. Now, what about the immunoglobulins, right? We talk about right here, there's a reduction in these immunoglobulins. What about these immunoglobulins? Because this is where things get really fascinating. Secretory IgA, immunoglobulin A, influences the composition of the intestinal microbiota, downregulates pro-inflammatory responses normally associated with the uptake, with the interaction of pathogenic bacteria or allergenic antigens. SIGA serves as the first line of defense in protecting the intestinal lining from enteric toxins and pathogenic microorganisms. So it's almost like instead of just the police force, right, which are the macrophages and those guys come in and golf and trap and go, it's like you also have a community safety patrol. In the community safety patrol, they may not have guns, but there's a lot of them, right? And people volunteer, right? And if someone suddenly is outside gangster shows up, or there's someone inside the town that's about to go berserk, right? Literally imagine if a whole blob of people came and trapped this person and literally just like, okay, you need to leave now. Promoting the clearance of antigens and pathogenic microorganisms from the intestinal lumen by blocking their ability to access the epithelial receptors. It's like ability to access the door handles to come into the homes, entrapping them in mucus and facilitating their removal by peristalsis and mucociliary activity. Basically, they boot them out. SIGA has been identified as having the capacity to directly quench bacterial virulence factors and influence the composition of the bacteria. By binding to bacterial antigens, SIGA can also limit the overgrowth of select species, thus stimulating diversity, keeping bad actors out, allowing the beneficial people, the kind, loving people to thrive. This antibody represents a key host mechanism in regulating the commensal community and innate receptor signaling in T cells. And seems to, in the T cells, right, the ones, the air traffic controllers, seem to decide the specificity of the SIGA to constrain the bacteria. So there's this super complex and fascinating interaction that's taking place where one cell communicates to another and it's like, oh, you need to go after that guy. Got it. We're going. So and so is having a psychotic break. He's about to go, ape shit on everyone, and you need to go. Got it. SIGA might be more reactive against disease-driving bacteria, and ultimately, by doing that, it limits the overgrowth of select species, allowing diversity. These are other studies that basically say the same thing, that they neutralize pathogens and help shape the microbiome. And you're welcome to go look. This is just a limited sampling. There's multiple other studies that have not been included. One of the things that's fascinating is it's not just that they bind to these bacteria and prevent them from getting into the gut. Recent evidence argues that these immunoglobulins also affect bacterial viability and pathogenicity, meaning they actually can influence how these microorganisms behave by disrupting their bioenergetic machinery, impacting the motility or ability to express these virulence factors. For literally, they may actually change the functioning and behavior of those gangsters where if these gangsters get surrounded by this group, if you want to say, or surrounded by this group of people, the bad gangster that was about to do all kinds of awful things all of a sudden chills out and it's like has this transformational change. This is how powerful these immunoglobulins and immune system effects are on the gut. These antibodies can also have antifungal properties. So that shape shifting, remember, psychotic break of candida may actually be controlled by the presence of these antibodies, which influences if candida goes through its morphological shift into the invasive hyphae form or stays in the benign kind of chill mode. And one of the things that's so interesting is that Dr. Shoemaker was talking about this in a certain way over 20 years ago. So Dr. Shoemaker found that there are certain immune haplotypes. And these haplotypes are basically how these human leukocyte antigens behave, which then ultimately determines the specificity of T cell and natural killer responses, right? So it basically influences how air traffic control kind of signals like, you need to go there, take care of this, right? And if there's certain genetic susceptibilities and air traffic control is not functioning properly and the proper signaling and antigen presentation is not taking place, that is where we get our 25% immune susceptibility to biotoxin illness. Now, why is that important and how the hell does that have anything to do with the gut microbiome? Our results show a statistical association between host HLA haplotypes and gut microbiota composition. Individuals with similar HLA genes have similar microbiota. The immune system is what is influencing the makeup of our microbiome. The immune system is what is influencing the health of our gut as a whole. Now, how does dampness influence the immune system? And how does this all come together to ultimately impact these children, right? Now, it's like, okay, if all of this is fine and dandy, now how the hell does dampness fit into the picture? So I love this study because I don't think it could have been said any more clearly. Trichothecenes are one of the mycotoxins that we see. Mycotoxins have a strong immunosuppressive effect, and they suppress the host immunity and make them more susceptible to infections of various pathogens. And I would argue that this also is relevant to the gastrointestinal tract. When you look at various studies and ask, how do these toxins influence, other things, right? So first thing is, when you look at where we get certain drugs that we use for transplants, right? Heart transplant, organ transplant, mycophenolic being one of them, cyclosporine being another. Those are derived from either fungi, and in the case of mycophenolic acid, is literally, you see right there, mycophenolic acid is a mycotoxin produced by penicillium. Stachybotrys, the classic black mold, can produce a cyclosporin-like compound that in rats, when given, it actually allows skin grafts to hold. And one of the things that I see all the time in at least 20% of the kids that have had exposure is this weird picture of a low white blood cell, usually with a low absolute neutrophil count. These kids don't have the C word. What they have is exposure to toxins that has disrupted their immune system. And when you get disruption of that immune system, guess what happens to the rest of the body and the gut? All kinds of weird things start showing up. Even in small amounts, right? Prolonged exposure to mycotoxins, even in subtoxic exposures in non-cytotoxic concentrations, meaning in theory it shouldn't be enough to cause toxicity, can alter the immune response. In this case, they gave these poor little rats, or sorry, pigs, IV administration of Dawn, which is a type of mycotoxin, and they asked, what does that do to the piglets, to the little babies? Significant decrease in the population of regulatory T cells, right? That's the traffic control cop, right? So it is what is needed to prevent excess inflammation and an increase in these cytotoxic T cells. So you get this weird pro inflammatory state, right, where these kids are highly inflamed in the nervous system, in the skin. They develop eczema, they develop gut inflammation, they develop all of this stuff. And in utero exposure may be driving some of that. But what's weird is at the same time, this is a study of oral exposure to ochratoxin, even in tiny amounts in little chicks was enough to cause a significant decrease in immunoglobulin bearing cells. Ochratoxin exposure decreased the antibody response in the pups of moms that were exposed, and similarly in chicks that were exposed. And ochratoxin is described as a modulator of the humoral and cellular, so innate, the macrophages, dendritic cells, and then the humoral, the B cells, the T cells, the antibody response cells. But there's more. So this is where we look at what happens with systemic exposure. It causes alterations in serum proteins and immunoglobulin profiles with reduced antibody formation. T2 toxin, reduced complement formation, diminished serum immunoglobulins, specifically IgA and IgM, and diminished antibody production. If the immune system that is there to protect us, right? Serum immunoglobulin A is the key factor in regulating and controlling the gut immune function and the microbiota, right? If that entire system, you've got the volunteer side, you've got the pro-police side, you've got whatever protective side, all falls asleep at the job, what happens to the inside and makeup of the gut microbiome? Bad things happen. And one of the things that I have become really certain about, and again, it's still a working hypothesis, so we don't know for sure, is that this very abnormality in immunity is where these persistent, severe, chronic gastrointestinal dysfunctions come from in individuals that have been exposed. And that is the root cause of chronic toxicity. The chronic biotoxin illness is because the gastrointestinal tract and its immune system just never functions properly to protect the host, not just from the toxins that are from the outside. Because once you get gut permeability, and I've talked about this in some of my prior presentations, once you get significant gut disruption, you get gut permeability, that allows the entry of all of the bacterial endotoxins from within us. It allows the absorption of all kinds of other microbial compounds, Clostridium toxins, HbA, 4-cresol. It allows all of these to start entering into the bloodstream, which changes the neurological functioning here, causing all kinds of weird abnormalities within the nervous system, within the immune system, on and on and on and on. And what do we see in these little kids? So this was a study probably that I did 5 years ago, maybe longer. And at that time, I had started asking, what is going on in the gastrointestinal tracts of these children? Like, why do these kids have such odd gastrointestinal tracts? What is going on? And I looked to see if I can find diagnostic tools that can help me assess this. And, after looking at everything that was out there, because, checking things like blood zonulin levels are highly inaccurate. Stool testing, kind of accurate, but not really. Ultimately, I landed at these immunoglobulins, so antibody responses to the gut. And essentially what we're doing with this is this notion that if the gut becomes compromised enough, right, if the gut barrier is now broken, the immune system is going to start interacting with whatever is inside the gut or within the cell layers. And that immune response then could become a surrogate way of checking to see how much disruption there is within the gut. Now, this was one of the tests that kind of had me open my eyes because unlike the other tests that basically say, well, 0 to whatever amount is fine, this test pointed out like if the immune system is too low, that's actually not a good thing. And now we know that it's absolutely not a good thing because you need a certain amount of immunoglobulin A in particular, and you can argue these other immunoglobulins to function at a level that is protective. So then I started doing more tests and kept finding similar patterns. There's a company called KBMO. I didn't include it over here. I love their test. It's a finger prick test. And when I started running their tests, I noticed that everything was normal. So I reached out to the lab and I was like, hey, can you guys give me the quantitative data, like the actual data? And over and over and over again, my patients were in the negative 99th percentile to the point where the lab director reached out to me and he's like, Pagebin, this is like really weird. We never see such low antibody reactions in all of the tests that we run. What the hell is going on with your patients? And these conversations, and now I've run hundreds of these studies, kept showing a similar pattern where the immune system is asleep at the job. This is a test created by my mentor and friend, Dr. Ari Vojdani, where he created this test looking to see how the immune system reacts to candida, especially when candida starts having a psychotic break. So candida lysine is a compound that is released. These germ-true proteins, these alpha enulase, are basically compounds that are released when candida becomes a gangster. It starts causing all kinds of really bad things to happen. So brilliantly, he said, well, let's create a test to look at how, if the immune system is interacting with candida. And one of the things that I've seen, and now running a bunch of these tests as well, is below detectable level, below detectable level. And if you pay very close attention, IgA, below detectable level, below detectable level, below detectable level. These children do not have an abnormal immune response. And in talking with some of the labs, the results that I'm getting, at least with some of the tests, are below what they would typically see in other children. So what's behind this immune suppression, right? If this is all true, and again, this is a working hypothesis. It's not like we have published data to confirm all of this. We are taking published data and connecting the dots, which I find clinically to be relevant to the patients that I take care of. But what's behind this immune suppression, right? What is this all about? So this is where we get into the world of immuno-metabolic, immunometabolism. Currently, the mitochondria may be considered as the master metabolic regulator of T cells, implicating that by controlling mitochondrial metabolism, we could control lymphocyte fate and function. Different study. The mitochondria act as a master regulator to fine-tune the immune response elicited by macrophages, right? The front cell police, you can call them the army because they just attack, right? They go and destroy, versus the T cells more like the air traffic control cops. Exhaustion of the air traffic control is a hallmark of cancer in persistent infections, and I would argue that this would extend into the gastrointestinal tract of these children because they have persistent dysbiosis that does not improve with typical measures and standards, marked by inhibitory receptor upregulation, so signaling channels are basically gone, right? Diminished cytokine secretion, impaired cytolytic activity. What the hell does that mean? Air traffic control, army, police, volunteer forces are all asleep at the job, and the communication lines, even if some of them are awake, are broken. So they're like walkie-talking each other, except the walkie-talkies are also out of battery. So no one's talking to anyone. The entire immune system is kind of missing the point and not doing its job. We showed that mitochondrial insufficiency is a cell intrinsic trigger that initiates the functional exhaustion of our traffic control cops or air traffic control. When air traffic control is asleep at the job, you get Candida acting like a gangster because no one is paying attention to what it is doing. Now, the T cells don't influence our immunoglobulin production. It's the B cells. And if you look at how B cells function, so B cells are kind of, regular ordinary people. They're just kind of chilling, right? They hang out in the place, right? Imagine a base where they're all just kind of chilling, and they don't always do anything right away. It's kind of what is needed for them to do that they then go and do it. So differentiation of naive B cells in Peyer's patches, which are basically these bases that they live in, to IgA plus plasma cells. So this is when yo, all of you people in that base, you all need to get going. We need you to step up and start producing IgA because we've got a problem, right? Traffic control, air traffic control. Hey, you guys need to step up from your base, start producing these antibodies because we've got some protecting to do. Imagine if all of the people in that base have chronic fatigue. They get the signal, presuming air traffic control is not asleep at the job too, right? But they get the signal, but they're so chronically fatigued, they're like, God, I don't know if I could do that. That's a lot of work. Because it is a lot of work. If you actually sit down and really reflect on it, literally these cells have to go through a complete transformational change. They literally morph into a different kind of immune cell, even though it's part of the same cell line, but they change into another immune cell that then starts producing this IgA, and that requires a metabolic shift. Regulation of the mitochondria is likely critical for the development of B cell lineages. So when B cells have chronic fatigue, and for those of you who have had chronic fatigue, you know what that feels like. You can't think, you can't function, you can barely get out of bed, you just... Why can't our cells have that? Why can't they experience that? They do. They do. Defective mitochondrial remodeling in B cells leads to an aged immune response. So in this case, they took these cells, and it was actually mice. They knocked out the ability for the mitochondria to reproduce, to replenish themselves. And what they found is when they encountered an antigen, hey, you guys need to step up your game. That led to an inadequate immune response with this immunodeficient phenotype characterized as severe blockage in activated B cells. Another study saying the same thing. Alterations, natural killer cells, are another one of our innate immune cells that are needed to basically just go and attack. Alterations in the metabolic profile of these natural killer cells also influences their behavior. Mitochondria are essential for the fate of both adaptive and innate, and shown that mitochondrial dynamics also are critical for macrophage. So these are like first line, if you want to even call them the Marines, right? They just plow in there to take care of infections. Imagine the Army, the Marines, the police, the volunteer squad, the air traffic control. Everyone has chronic fatigue. Their walkie-talkies aren't working. Signaling and communication just kind of got shut down, and everything is just going to hell. Is that why these kids are getting so sick? Is that why these kids are so badly affected? I believe so. And if we can understand how this is influencing the immune response and take care of this, how can we help these children recover more effectively, more efficiently? Once the Rangers, the whatever, Green Berets, they're triggered and they're now freaking out and they're going guns blazing, It turns out that if the mitochondrial macrophage of these macrophages is suppressed, their ability to chill the hell out once they've been activated is also influenced. And one of the things that I commonly see in children with PANS and PANDAS and autism is they have this M1 polarization of the macrophages, which are the microglia, right? The microglia are macrophages of the brain. They get activation of the macrophages of the brain. These immune rangers go buck wild and they're just ready to shoot everything and anything they see, and they're just kind of paranoid with a little bit of PTSD, and they cannot chill the hell out. Why itraconazole works is it basically becomes a signaling of like, you guys need to chill the hell out. Okay, I'll chill the hell out. You use peptides, they chill the hell out. You use various other things. What happens when it's gone? When those signaling things are gone? In 10 to 20% of the kids, the microglia just rev back up and go into full-blown berserk mode. And that is likely due to this mitochondrial error. Now, the big question is, how the hell does dampness influence all of that, right? If all of this is true, then how the hell is dampness causing this mess, right? Because maybe it's not the direct effect on the microbiota. Maybe it's not even the secondary effects on the gut. Maybe it's the mitochondria. What the hell do these toxins do to the mitochondria? A few different studies. The most severe mitochondrial errors that I have seen in any patient subset are in those who have been exposed to dampness and mold. Now, it's not to say that heavy metals can't do it. It's not to say Lyme and Lyme co-infections can't do it. They absolutely can. Glyphosates can do it. Plastics can do it. All of these things can do it for sure. But if you talk to enough adults who have been exposed to dampness and mold, what you also find in those adults are people that are just burnt. That was actually one of the terms that one of the moms recently used. I'm just burnt. Like I have zero capacity to function. That zero capacity to function is rooted in significant mitochondrial errors. And essentially every single part of the electron transport chain and the mitochondria can be impacted, from the membranes to these parts of the electron transport chain. Like you can see everything, including this pump that produces ATP, is impacted. So it's like having a conveyor belt. Imagine a conveyor belt where a car is being assembled or something is being assembled. And literally every single part of that production process is somehow messed up. And what you get on the outside looks nothing like what was supposed to be. The car has a wheel on the roof and it's missing a door and there is no engine because the people forgot to put it in, and everything is just mucked up. Trichothecenes, one of the mycotoxins, can inhibit mitochondrial biogenesis. And if you go back and you look, where was it? Right here. Mitochondrial biogenesis was one of the things right here. Here we go. So when you knock out mitochondrial biogenesis, you get a severe blockage of activated B cells. Trichothecenes inhibit mitochondrial biogenesis and mitochondrial respiration. And also, if that wasn't bad enough, they can also alter mitochondrial transcription and translation, which basically they need to repair themselves. And we know that these toxins are being absorbed. We know that they're going into the bloodstream. We know that they're at play. But it gets worse. When you get inhalation of these endotoxins, and you can argue other microbial particulates, and mycotoxins to some extent, you also get triggering of weird inflammatory, pro-inflammatory cytokines, interleukin-6 being one of them. multiple studies. When you get that pro-inflammatory cascade, that also causes damage and dysregulation to the mitochondria. Interleukin 6 drives mitochondrial dysregulation, accelerates physical decline, chronic inflammation through cytokines, impair mitochondrial oxidative phosphorylation, which is basically that little pathway, and ETC is electron transport chain activity, blah, blah, blah. If that wasn't bad enough, there's valinomycin. So actinomycetes, which actinomycetes, or actinos, as they call them, is something that Dr. Shoemaker has been paying a lot of attention to. And one of the things that these gram-positive bacteria produce is valinomycin. I encourage you all to go look this up yourself. Valinomycin is what researchers and scientists use in laboratory settings to induce mitochondrial damage and errors in various clinical studies because it is so effective at damaging the mitochondria. Literally, labs all over the world are using this compound that comes from damp environments to cause mitochondrial damage when they want to study what the hell happens if you screw up the mitochondria. In low doses, valinomycin uncouples oxidative phosphorylation and causes dissipation of the mitochondrial membrane potential. What the hell does that mean? So uncouples means like this entire little, you see this little 1, 2, 3, 4. Uncoupling is basically you disrupt this thing, so ultimately this electron gradient that you need to produce ATP is completely mucked up, and ultimately nothing is happening. And this notion of dissipation of the mitochondrial membrane potential. So imagine you've got a balloon, right? And the more you puff up this balloon, the more energy is stored, and then that causes ATP to be produced that then drives cellular functioning, right? Gives our immune cells energy. Imagine you had something that let all of the air out of that balloon, so there was no energy to produce the ATP. The dissipation of mitochondrial membrane potential is basically letting all the air out of the balloon, which then causes the balloon to shrink, which then causes the lack of energy production. Valinomycin triggers the rapid loss of mitochondrial membrane potential. Valinomycin has been used to dissipate the membrane potential of cells and mitochondria, induces mitochondrial cytochrome C release. 1 in 3 individuals are being exposed to these toxins, and we're not talking about it. No one is even paying attention to it, including many people in our functional and holistic communities. There are so many children and individuals who are being harmed in unbelievably and unimaginably profound ways, yet we're missing it. We're missing it all the time. And we go looking for all kinds of other things, yet the elephant in the room is completely overlooked. And as I presented in the past, part of that has to do with our very inadequate environmental inspection standards, where well-intending providers say, hey, you may have mold. No, we tested our home. We don't have mold. Okay. Or it gets missed on diagnostic testing because the provider doesn't know how to test for this properly. So they they think about it. They run the test that they think is best. They run a urine organic acid, which I love. But urine organic acids miss this 50% of the time at the very least. They run regular labs, which misses it 100% of the time. And they go on to treat everything else, missing the root cause of what may be happening. And if you ask, well, how do you know this is happening in the kids? It's because of this. I can't tell you how many children I've tested for mitochondrial errors, and you give me a kid that's been exposed to dampness and mold, and I'll give you a test that shows that there's a mitochondrial error. And we don't even need these tests. So this is it the most perfect test? No. There are plenty of, researchers like Dr. Bowles that say, yeah, I mean, for a cheek swab, it's as good as it gets, but it certainly is not perfect. But you don't even need this test. You can see it in the children. They're exhausted. They're depleted. They can't focus. They can't think. They have brain fog. They get exhausted every time they try to run. They just lack energy and vitality. You don't need a test to tell you that that child's energy production is compromised. You can see it. This is happening to so many individuals. And these mitochondrial metabolic errors then cause a cascade of other events, which disrupts the mitochondria, leading to immune dysfunction, leading to gastrointestinal dysfunction, leading to persistent gastrointestinal changes that are very difficult to address. Do we know that all of this is 100% accurate? No. Do we even know the full extent of the toxins that are being released? No. There are studies coming out that are finding new mycotoxins that we didn't even know were being released. Do we know that there are other bacterial products that are being released into these environments? No. We are literally barely scratching the surface of our understanding of this. But even with that limited amount of data, once you piece it together, you see how all of this is connected. And you see the probability, the high probability that this is all being driven by biotoxin illness. We need to do a lot more research. There's no doubt. As I started in the beginning, this is a working hypothesis. Do I know for sure with 100% certainty that this is the case? No. But are all of these clinical findings common in the children that we see? Absolutely. And how does this ultimately impact the autism spectrum? How does it impact other conditions? I think it plays a significant role. Do we know for sure? No. The most important part of this conversation is that this exposure could be prevented. What drives me is thinking of a day when no one has to become sick because of the environment in which they are living in, going to school in, working in. And the amount of health cost savings are probably beyond imagine in the trillions of dollars. The damage and harm that's coming from this exposure is treatable. And there is profound healing that can be had, whether it's just within autism or other conditions, by just addressing the exposure and doing some things to start detoxifying the child and the individual. There's so much good we can do for our society. There's so much good we can do for all these children. And for me, the most wonderful gift that I get to enjoy is when I'm on a journey with a family and I get to see and witness with that family the healing of their child, where that child is now connecting with the family, whereas they couldn't before. The child that was having freakouts and meltdowns and becoming overwhelmed by the world is now the kid that's able to sit and go to a classroom. They're able to go to church. They're able to go to a restaurant. They're able to be in this world. It's the coolest thing when the child that was failing out of school, couldn't focus, couldn't process, couldn't retain anything, is now the smartest kid in the class. And they're reading and they're doing math and their entire future is different. This is how powerful this conversation is. We can literally rewrite the life trajectory of millions of people. 1 in 3 individuals are exposed. 25% of those individuals are genetically susceptible. We can literally rewrite the future for millions of children and adults by having these conversations and understanding how these conversations are impacting the individuals in our society. With that, I want to thank you for taking the time to watch this presentation and to just take this information in. And I encourage you all to go do your own research, go connect your own dots, and you'll see that there is more and more data to implicate these connections, and that this hypothesis may actually be more realistic and accurate than not. And with that, I wish you all well. This is Dr. K.